Okay, so now we're going to continue our discussion of the arithmetic operations by talking about subtraction. In my experience, if you were to ask 100 people on the street what they thought subtraction was, at least 99 would say some form of taking one number away from another. And while that is going to end up being an actual interpretation of subtraction, it's not a precise definition. And one of the as we mentioned in the introduction, one of the things we really want to focus on in elementary school is using really precise language, using the correct terminology, precise definitions. It's going to pay huge dividends down the line. So if we are going to define subtraction precisely, we want to define it as the inverse of addition. So oftentimes at this level we will accompany our precise definitions with number sentences. So what we mean by the inverse of addition is that 11 minus 6, that is the number that adds to 6 to return 11. Okay? And there's going to be benefits of thinking of subtraction in this way, as we'll talk about here in a little bit. Okay? So, as we mentioned in the last clip, there are two kind of main things we want to get across when we talk about the arithmetic operations. One, of course, is that we want kids to be able to compute, and we will talk about computation here in a bit. But the other is we want kids to really understand these operations, the concepts, the meanings of these operations. Again, our main goal is solving word problems, and we want kids to be able to take a real-life situation and reduce it down to the correct arithmetic. Now, with addition, that's pretty easy, frankly, because there's really only one way in which addition comes up in the real world. You have a quantity, I have a quantity, we want to combine it together to make a sum. Subtraction, on the other hand, is a little trickier because there's actually three different ways that subtraction appears in the real world, and they're fundamentally different from one another. We call these interpretations of subtraction, so let's talk about those for a second. The aforementioned takeaway interpretation is probably the most commonly thought of interpretation. Again, with takeaway, we start with a whole and we physically reduce that quantity by a specified amount. So, for example, we might have the following problem. James had $11. If he spent $6 on a truck, how much money did he have left? Okay, that's, again, an example of takeaway subtraction. We started with a specific amount, 11. We've reduced that physically by a certain amount, 6, and we want to figure out how much we have left. Now, what we're going to end up doing when we solve word problems is drawing bar diagrams to illustrate the arithmetic that is happening in an individual problem. So we want to associate a particular bar diagram to each of our interpretations. One way to draw a bar diagram for the takeaway interpretation might be as follows. We might draw an entire bar that represents 11, and then the part that we take away represents 6, and then the question mark represents what's left over. But again, takeaway is not the only way that subtraction comes up in the real world. There are other fundamental situations that are different than takeaway that still reduce to subtraction. And kids need to see that, because if kids think that subtraction is just takeaway, what's going to happen when they encounter a problem like the following? That is not a takeaway interpretation. The following problem reads, a class of 11 students contains 6 girls. How many boys are in the class? So this is not takeaway. We're not reducing the whole number by a specified amount. Instead, what we have in this situation is we have the whole, in this case 11, and we know one part that makes up the whole. That's what the 6 represents. So this is something we might call a part-whole interpretation of subtraction, because again, we know one part, we know the whole, we wish to find out what is the other part that makes the whole. But again, this is still a subtraction problem. Again, if we wanted to illustrate this in a bar diagram, you'll notice that this bar looks almost identical to takeaway. I kind of just included it for completeness. We might have a whole that represents 11, one part of it represents 6, and the missing part is what we would represent with our question mark. There's even a third way that is different than takeaway and part whole in which subtraction comes up in the real world. This is what we would call a comparison interpretation. So for example, if James has 11 trucks and Julian has 6, how many more trucks does James have than Julian? And I apologize for the lack of imagination in my word problems. I have a son named James and he likes trucks. So we have a fundamentally different situation here. We are comparing two quantities. We want to know how much larger is the bigger quantity than the smaller quantity. So we might have a bar that represents each of the quantities. So one bar representing James's trucks, which we would label with 11. Another bar representing Julian's trucks, which we would label 6. And now we want to represent the answer to this question in terms of the difference in the lengths of the bars. So the question mark in this case would go right here. How much longer is the 11 bar than the 6 bar, i.e. how much bigger is 11 than 6 is the question that's being asked here. Okay? Incidentally, the comparison interpretation can often be really tricky for elementary school students. And the reason why is this word more. Oftentimes students are taught via keywords, so they're taught that certain words always mean something in particular, and oftentimes students are taught that the word more always means addition. Okay, so this is why when we talk about solving word problems with bar diagrams a little later, we are really going to encourage drawing pictures like this, because what we don't want is for a student to read a problem like this, say on a standardized test, and just see this word more and answer the question 11 plus 6, because of course that would be one of the incorrect answers. Right? We want students to connect models or bar diagrams with particular problems, and then hopefully they'll be able to connect a diagram that looks like this, to the operation of subtraction. Okay, so again, just one last word on interpretations. Takeaway part-whole comparison, oftentimes these are kind of teachers' words. We don't really need students to know these words, but students need to be aware that all three types of problems all reduce down to subtraction. So when they encounter all of these three types of problems in the real world, then they can figure out that subtraction is necessary for all three. Okay, so as a teacher, what we need to do is we need to make sure that we ask our students a variety of word problems involving subtraction and not just take away, take away, take away all the time. Okay, so again, of the two main things we want to talk about with operations, one of them is just understanding what the operation is, and that's what we mean by definitions, models, interpretations. But of course, we're also going to need to learn how to compute. Okay, so we also have some thinking strategies that go along with subtraction. But you'll notice that, it's a good thing I didn't erase the definition of subtraction can actually help us with computation. Think about if a student just learned subtraction by takeaway and they were thinking of 11 minus 6 as taking 6 away from 11. That doesn't shed any light on what the actual answer to 11 minus 6 is. On the other hand, if a student can connect 11 minus 6 to either of these addition problems, then, of course, in a perfect world, the student already knows their addition facts at this time, and they can think to themselves, well, the answer to 11 minus 6 is the same number that adds to 6 to get to 11. So that can help them with their subtraction computation if they can connect them to addition computations. And a really nice feature of the Singapore text are what are called number bonds, and you will see these in the lower grade textbooks. So number bonds are simply pictures that look like this. So for example, we might have the following. So we're bonding together a 9 with a 6 and a 3. And what a picture like this does, and this is a kind of a main feature of the Singapore text, is they have pictures that don't take up a lot of space and use a lot of words, but they really convey a lot. So there are actually 4 facts that are conveyed here, right? 6 plus 3 equals 9. 3 plus 6 equals 9. So not only are individual facts conveyed, but the commutative property of addition is conveyed as well, right? Because we see that 3 plus 6 and 6 plus 3 give the same answer. And not only are these addition facts conveyed, but also the corresponding subtraction facts. 9 minus 3 equals 6. 9 minus 6 equals 3. So if we combine the definition of subtraction together with things like number bonds and some mental math strategies that we'll see a little bit later, that will allow us to solve subtraction problems within 20, which are necessary in the subtraction algorithm, as we saw earlier.